Hello everyone, and this video is going to be over a quick review over chapter 3. It really is just bullet points over main topics and interpretations. So if you have your notes, I would highly suggest finding them as you go through that AP practice. But let's just get started. So first we talked about explanatory versus response. So explanatory is your X variable, and it explains why something happened. The way I think about it is it's what you control. Should be your explanatory, and we can remember explanatory is the X variable because it has an X in it. I guess it also has a Y, but the X comes first. And so then the response variable, it measures the outcome because of what you're controlling. So it's what you're trying to predict. And that's going to be your Y variable. Okay, so those are just vocab words for X and Y. And then when you want to compare these two variables, that means you're comparing two quantitative variables, so we use a scatter plot. And make sure if you are drawing this to label your axes. So after you create it, then we want to find a way to predict using our least squared regression line, which we use this format, y hat. Remember, y hat is your predicted value for any given x value. And A would be your y-intercept. So the interpretation we use is when x is 0, but you don't put x. You say whatever it is in context. When height is 0, y is going to be about whatever A is. And make sure you use that word about. And so then B would be your slope, and the way you interpret slope is for each additional x, which again should be in context, the y either increases or decreases depending if it's a positive or negative slope by about B. Okay, just make sure you use context for your x. And speaking of context, when you write your least squared regression line down, you need to make sure you define y hat and x. Okay, so you need to say what is your response variable and what is your explanatory variable. X is height, y hat is predicted weight, or whatever it is for that problem, where you write it out in words. Let me make sure I'm not forgetting anything here. So let's label that A was your y-intercept, B was your slope. Now I didn't put on here how to do it in the how to find this in the calculator. So I am going to encourage you to look that up in your notes. Or you know what, maybe I'll show you real quick, I lied. But if you know how to do the calculator, you can skip ahead. I just figured some of y'all might not have your notes or something. So, oops, I already did the wrong thing. What you should go to is, hold on, list and spreadsheet, label, put in your X, put in your Y, type in your data, whatever it may be, and then you go to your next column, to the row equals, and you go to menu, statistics, stat calculations, and linear regression A plus BX is number 4. And you pick your X, you pick your Y, keep everything else, and it'll give you your A, your y-intercept, your B, your r squared, your r, and residuals, which we'll talk about all that in a second. Okay, so where are we? Did we cover A and B? So the next thing is R. So what is R? It's called your correlation coefficient, and it's a number that's going to fall between 1 and -1, and so the closer it is to 1 or -1, the stronger the line. So it tells you strength and direction of your linear relationship, right? So if you look at your notes, we use this scaling that goes from -1 to 1. So if you are at 0, that means there's no correlation. And if you are between 0 and 0.5 or 0 and negative 0.5, that would be a weak correlation. And then the stronger, or the closer you get to 1 or negative 1, the stronger it is. So normally we say about 0.75 is when it, after that is when it starts to be, what am I writing? 0.75 is when it starts to be strong. And so if it's negative, then that would be a negative slope, and if it's a positive, then it's increasing, it's a positive slope. So it also tells you the direction, positive or negative. Now I'm sorry, my dog is barking. 1 second. I wanted to say that your R is theoretically, you use R after you determine it's linear. Okay, so R, just because it's 1, doesn't necessarily prove that your data has a linear relationship. It could still be really close to 1, but it actually may be better exponential or another type of relationship. So don't use R to determine that it's linear. You should use R after you already determined it's linear. Now you're trying to decide how linear. Okay, so I'm going to make a note. Don't use to determine linearity. Oh, and the other thing is that R doesn't have units. So, right, your X and Y have units, which mean your A and B also have units, but your R is just a measure of correlation. There are no units. So how can you find R? You can get it from the calculator, or if they give you R squared, you can take the square root. But then you have to make sure when you square root that you take the sign of the slope. So if it's a negative B, you need to make it negative R. If it's positive, you make it positive. Because square root, it could be positive or negative. And so then R squared, what is R squared? It's the coefficient of determination, and it measures the amount of variation between the variables. So the interpretation you use is it's the percent of variation in Y that is explained by X. And you want to make sure you put Y and X in context of your problem. So this is just a little way to help you remember these interpretations. So these are your interpretations that I'm starring. One for A, B, R, and R squared. It's the only one that you start talking about Y first and then X. On A, you talk about X and then Y. On B, you talk about X and then Y. So on R squared, you talk about Y and then X. But yeah, you need to know, because sometimes they're not going to say coefficient of determination, but they're going to say 67% of variation in Y is explained by X. What is the correlation coefficient? Well, you need to know that that interpretation is for R squared. So you need to square root it to get R. And you can also find it in the calculator if it was a problem where it gave you the data. Where does it? I'll just wait till the end. Okay, so then if it just gives you S, that stands for the standard deviation of the residuals, which that is this interpretation. It's the average amount that the observed Y differs from the predicted Y is about S units. So it's how much is the average amount the observed differs from the predicted. So what is a residual? Because that kind of ties into that. It's that idea of finding what's the difference between your observed Y and the expected Y, which the expected Y should come from your regression line, Y hat. So you find Y hat by using your least squared regression line, and then they would have to give you the actual Y so you can find the difference, the residual. So what it is it's giving you how off your prediction is from the actual. But you need to do it in this order. It has to be Y minus Y hat. And I think I told y'all that you have to have the Y before you put the hat on the Y. That's kind of the way I don't mix it up. So what does that mean is if you have a negative, I'm going to actually write negative because that looks like a bullet point. a negative residual, would that mean that you're overestimating or underestimating? Well, let's think, how would this be negative? What's bigger than? It's going to be negative if you take away more, if y hat is larger than y. So then that means you overestimated. And so that means if you have a positive residual, oh my goodness. Well, how would this be positive if y is greater than y hat? So then that would mean that you made an underestimate. So the sign of the residual is important. That's why the order that you write your equation is important. So then let's say for every single observation, on every single point on your scatter plot, you found the residual, and we put all those residuals on their own plot. That means that it should be positive and negative, right? Because you can have negative residuals. And so for every x value, you put the residual is the y value. Resid is sometimes how they abbreviate it when they label the axis. And so you put all those on there, and so what are we looking for is we're trying to see, is there a pattern? Remember, if there, what is a residual plot for is it helps you determine if there's a linear relationship, and it's kind of backwards. It's, let's say if there is a pattern, which that pattern could be anything, just it could be like a U or a curve going like this. Now it might not be perfect, but if it looks like it's following some type of curve, so if there is a pattern, then linear model is not appropriate. If there is no pattern, if the residuals just look random, then that's what you want. If there's no pattern to your residual plot, then a linear model is appropriate. Okay, so you can go back and look at your notes for that if you're kind of like, huh? We kind of did, I think, some good examples with that. Okay, I think that's everything for residuals. So these last couple things is an outlier. You know what an outlier is, it just lies outside. And then another word is the influential point. So it doesn't necessarily have to be an outlier, but it's just if removing the observation would drastically change your R, your correlation. And so you can just kind of tell if you would take away a point, is it pulling that least squared regression line up a lot or down a lot? What point is affecting it the most? Which is normally kind of separated from the other points. And then we have extrapolation. So what is extrapolation is if you use your regression line for prediction outside of the values of x, right? So you want to use only use your least squared regression line for the range of your data to predict something in that range. You cannot use your least squared regression line for something outside of the range of your data because the pattern could change. So it's not going to be fully accurate. So we don't want to do that. That is a bad thing to do. So then the last thing we talked about was how do you find your least squared regression line from summary statistics? And you have formulas on your formula chart. And I was just looking at your new formula chart, and there are some changes. So if you looked at the old one or you look at your notes, it was BO and B1 instead of A and B. But now they just keep it A and B. So if you're like, what is she talking about? You have to go look at your old notes and old formula chart. I'm not going to write it down here because now they keep your least squared regression line always A plus BX. So if they didn't give you the data, so you can't type it in your calculator, they just gave you the summary statistics. So if they just gave you what the mean of your X data is and the standard deviation of your X data and the mean of your Y and the standard deviation of your Y, they gave you those four things, then we could still come up with this. using these two formulas. So this is your new formula chart. This is your least squared regression line. So at first I was confused because I didn't see an equation for A, only for B. But they want you to use this. And then you solve it for A. So I'll write down how they give it to you. So I'm going to say formula chart. They give you the mean of y equals A plus B times the mean of x, so it looks like the same. So then you could solve that to figure out what your A value should be. So if we solve that for A equals the mean of y minus B times the mean of x. So that's how you're going to find your A value. And then they give you the formula for the B. It's R, so you would need to know your R also, which they would give that to you, times the standard deviation of y over the standard deviation of x. So you would just plug your stuff in, get your A and B, and then write your least squared regression line, and don't forget to still define your x and y hat in context. Maybe I should put R right here because they would also have to give you that. And this is just a random fact, is if I should have been more specific than just change. If you switch or interchange x and y, I'm going to cross off change and change it to switch. If you switch x and y, that's not going to change your R. Your correlation is going to stay the same. So just keep that in mind. And one more fact that's not on here that I want to write down is that we said association does not mean causation. Right? Association does not imply causation. So just because you have seen that there is a correlation between two variables doesn't mean that x causes y, because there could be confounding variables. Because association just means that there's strong correlation. What do you need to imply causation, which we'll get more into the next video, is an experiment. Okay, so I think that hits on everything from chapter 3. Oh, no it doesn't. Something that's not on here that I wanted to show you was a computer output. So this, I'm not going to read this whole scenario. I just wanted to show you this. You don't have this, just so you know. I just had to find it because I realized there's no computer output on here. If you want to write this down and label it, you can, or whatever you just want to watch. So when you're given a computer output, what does it tell you? This constant means that this is your constant, your A. Whatever they put right here is your x for your problem. So that's your x in context. That's what you're going to define your x as, which means this is the coefficient, COEF, for x. Well, what's the coefficient for x? Is b. So you can get your A and B. You shouldn't really need this stuff. This is your S, which we just said that's the average amount. I'm trying to make sure, average amount that the observed differs from the predicted. Here you have your R squared, so you can square root that to get, or change it to a decimal, and then that R would equal the square root of 0.207, and then you would check the slope here is positive, so your R is positive. You don't use R squared adjusted. Okay, so just wanted to make sure you saw a review of that as well. So that is chapter 3. Next video we'll cover chapter 4.